Hello, Lamai. Can you hear me?
Yes, sir.
Okay, very good. Today we are going to learn something really new and in a revolutionary way. So that is called project motion under gravity, right? Especially this motion under gravity, we can categorize into three different groups. Motion under gravity. What does it suggest? Huh? So I'm just keep moving now. So is that a motion under gravity or not? Hmm? Imagine like I'm on a car now. I just keep driving it. Am I in a motion under gravity or not? Yes or no? Yes or no? Hello? Say yes or no, whatever. Am I? Don't be introvert. Just say whatever the answer. Yes or no, I asked. Hello?
Yes.
I asked you if I just moving just on my foot or in a car, on a bike, whatever, in a train. However, am I in a motion under gravity or not?
Yes.
Yes or no?
Yes.
Okay, because my whole body is controlled by gravity. So gravity is just going to pull me to the ground. Isn't that? Isn't that? Yeah. Weight equals to mg. So I am under the control of gravity. Whenever I'm just in a car, on a bike, or kind of like in a kind of traveling in an aeroplane. Now moving in aeroplane, I would say is car, walking, and a bike, or whatever the moving method on the ground is not considered like motion under gravity because gravity is always acting on me, but there is a difference. Why? Motion under gravity stands for the entire motion is completely controlled under gravity as the only force. What is it? Say that again. Motion under gravity stands for what? The entire motion of the object is completely controlled by on gravity as the only external force. Here, when I am just on motion on this one, so the way gravity acts, yes, and the reaction force from the ground that also acts. So the force I just generate on the ground, that is the friction, also acts. And the force create on me, F equals to ma or whatever the force that acts. Air resistance acts and many other forces. So gravity is not the only force which control when I am on the floor and walking or riding or driving or whatever the incident that happened, or somebody dragged me along, whatever. The thing is not motion under gravity because gravity is there. Yes, gravity is there, but gravity is not all sole force, right? Have you seen like sole agent? That means he is the only agent that can kind of import this good to Sri Lanka, something like that. But here, the gravity is not the sole force of forces. Other forces are also acting on that. So it is not a motion under gravity. Okay, understand? Say yes or no.
Yes, sir.
Hmm. Now this is not definitely not okay. Now, in case of the plane, how about it? Is that a motion under gravity or not? Yes or no? Tell me. Now it is my turn to move in a train. Sorry, plane. Sedingan. Is that a motion under gravity or not? Lamai. Is that a
Yeah.
motion under gravity or not? Again.
Yes.
Huh?
It's motion under gravity.
Yeah, now it is just by a kind of like crane. I'm letting certain object to lift upward with an acceleration under tension of T. I just lift. It is like this one. Lifting it up and just keep moving in the air. Is that a motion under gravity or not? This motion, see, moving up, moving forward. Is that a motion under gravity or not? Tell me.
Motion under gravity.
Yes.
It is not. This is not. Don't you still understand? I told you the only force it should be gravity. Here gravity is there, yes. Aerodynamic lift, that lift force is there, gravity is there, and the thrust force, forward force is there, and the air resistance there here, tension is there, and the weight is there. So gravity is not the only force in those cases. So you can't consider these incidents, even it is in moving in the air, forward, backward, reversal, whatever the direction, it is not motion under gravity. Why? If the whole motion is supported by other forces, sources of forces as well. Understand? තේරුණාද?
Yes, sir.
ආනං හා කියන්න නැත්තම් නැහැ කියන්නේ.
Yeah.
Okay, now it is like motion under gravity means none of these. So only 3 types of motion you can consider as motion under gravity. So actually there are like 4. So first thing is free fall. Now have a good look at free fall. Once I release, so this condition, it is under gravity, but my force of from my hand is still applying. That is why it is in flotation. Why? Once I release, it is no longer held by anything else. The only force at this moment is what? Gravity. Understand? අතෑරියට පස්සේ gravity විතරයි. But there is a certain force that is air resistance. Air resistance. But we consider this air resistance is negligibly smaller than mg. So we assume that the air resistance is not gonna count. Actually, does you will happen to know in the end of these sessions, there is a lesson called viscosity. In that one, you will get to know the air drag, aerodynamic drag is definitely significant. And the upthrust also upthrust is also kind of significant. But here, for now, we don't consider about upthrust, we don't consider about aerodynamic race, aerodynamic drag, because why? For mechanics part only, we assume like for the projectile motion and stuff, motion under gravity, we assume the aerodynamic lift and the upthrust created by the airspace is kind of negligibly smaller. Understand? Okay. So මේ දේවල් මම notes දෙන්නේ නෑ ළමයි. මේ කියන යන දේවල් ඔයාලට හිතෙනවා නම් ඒ දේවල් පොඩි note එකක් දාගන්න. හරි? Now right. There are basically, sorry, did you write the big topic motion under gravity? Sorry. Yeah, motion under gravity. So, right, there are basically 4 different types of motion under gravity. There are 4 different types of motion under gravity. හොඳට බලාගන්න. 4 different types. Number 1, free fall. Number 1, free fall. Free fall. Number 2, vertical projectile. Projectile. Number 3, horizontal projectile. Number 4, projectile. Third, at an angle. Projected at an angle. 2, horizontal. So we are going to learn all of these 4 separately. What are the 4? Free fall, vertical projectile, horizontal projectile, projectiles at an angle to the horizontal. Okay. Now just write free fall. Free fall. Free fall. What do you know about free fall? There is an upthrust, there is a drag force. Like this. In the case of free fall, it is just a dropping of an object freely closer to the earth's surface. It is only valid for something closer to the earth's surface. We can't calculate it for few kilometers up, like maximum of few hundred meters. It is valid. But for our calculations, we take like a few kilometers, 2 kilometer, 4 kilometer height even. It is not valid actually, but we consider for our mathematical approach. But actually, it is not going to be ideal. But here, how we look at mg downward, upthrust is there, drag is there. So write this in a new line. Falling of fruit from a tree is a good example. Falling of a fruit from a tree is a good example. Okay. Now we look at here. The example, write this in a line. The example given in the example given in the diagram, given in the diagram, the example given in the diagram. This is a good demonstration of a free fall. Good demonstration of a free fall. Right. Good demonstration of a free fall. Here, the driving force is weight of the object. Weight of the object. There are 2 other forces, that upthrust and the aerodynamic drag. There are 2 other forces, upthrust and the aerodynamic drag. Also act on it. Mother, say yes if you understood. Lamai.
Yes, sir.
Yes, sir.
But for the mechanics, write this in a new line with a star point. But for mechanics, we consider drag force and the upthrust. And the upthrust together even way more smaller than the weight. Way more smaller than the weight. Copy this now. Way more smaller than the weight. So the only external unbalanced force is mg act downwards. Act downwards. Act downwards. So the only force is mg now. All right. As a result of it, according to Newton's second law of motion, F is equals to ma. F means mg is equals to ma. So finally you can cancel m and m. So the acceleration which is downward is only equals to g. Okay, acceleration is only equals to g in this case. I hope you understand. Right. Now write this in a new line. Did you copy this thing? Lamai kata karana class ekedi.
Yes, sir.
Huh?
Yes, sir.
Yeah.
Okay. If this is the only acceleration, now right? The only acceleration for free fall is gravitational acceleration. It is a fixed constant. It's a fixed constant. So acceleration under gravity is nearly, we can consider nearly, right? Not exactly 10 ms minus 2, because the actual value is also nearly 9.81. But we consider for our calculations, for our easiness, gravity as this value. That's easier. Okay. Now write this in a new line. This whole scenario can be, considered in likes of certain object started to move under an acceleration of g. Write this in a new line. Mathematical approach to the motion under gravity. Okay, this is the initial height. You release it. At the beginning, u downward is just 0. just write a subtopic. Dropping certain object from a height of simple h just above the ground. Now it may land here with the velocity of v. That is something we don't know. But we know all the time there is a one thing it does not change. What is it? The gravity. Gravity. And it started at a time of 0. It will reach to a time of somewhere t. That is also an unknown fact here. Copy this diagram very quickly. Very quickly. After you copying it, just write. Initial direction of the motion. Initial direction of the motion of the object is downwards according to vectors. According to vectors. The acceleration due to gravity. The acceleration due to gravity. Acceleration due to gravity is also act in the downward. Is also act on the downwards. So for this motion, gravity is a positive value. Gravity is a positive value. Okay. Gravity is a positive value. I hope you understand. Hurry. Gravity is a positive value. Now let's try to find out for velocity here. Velocity. Final. Sorry. How to find out? V square equals to u square plus 2as. U is 0. V is equals to the square root of 2gh. You can use this and find out velocity. Very easy. In the similar manner, time of motion. Time. How to find out time? We can apply s equals to ut plus half at square. So u is 0. H equals to half gt square. T equals to 2h over g and the square root of it. Very easy. It is very, very easy. Is that hard? Yes or no?
No, sir.
No.
Mm.
Now let's try to do some simple, very simple calculations. Write this in a new line. Find out the velocity of a cricket ball which hit the ground that it was dropped from a height of 45 meters above ground. 45 meters above the ground level. Now the height factor changes. It is some 45 meters. What can I do? I can apply to this equation. V equals to u square plus 2as. Don't remember these equations. I'm just going to apply with the basics. Okay, I can go for my value of v, I don't know. Value of u, I know it is 0. Value of a, I know that is g. Value of displacement, that is 45 meters. So time is not asked. I don't want to worry about. So my variabilities are v, u, a, and s. My equation going to be v square equals to u square plus 2as. I'm going to substitute v square equals to 0 plus 2 times 10 times 45. V square equals to 900. V is equal to square root of 900. V will be just what? 30 ms minus 1. Very simple. Very, very, very simple. Copy this.
Okay, sir.
Okay. Now I find out the time taken for the above mentioned motion. So I'm not going to use this equation straight away because I can apply the very basics what I know. Here, u equals to 0, a equals to g, time is something I don't know, s equals to 45, and velocity I don't want to. So my equations are going to be 1, 2, 3, 4. There are 4 variables u, a, t, s. So the equation going to apply is s equals to ut plus half at square. So u equals 0. 45 is equals to half times 10 times t to the power 2, just 5. So t to the power 2 is 45 over 5. So it will be 9. T square is equals to 9. T is equals to 3 seconds. Very, very simple. Now let's consider how this motion take place in each second. If I consider certain motion just above a certain height, I don't know, t equals to 0, you for the t equals to 1 second. 1 second. So let me just find out the velocity. Here the velocity is equal to 0. Here there will be a certain velocity, I don't know. What can I do? I can apply to the above equation. V will be like what? U plus at. So V is equals to 0 plus 10 times 1. It is downward. 10 ms minus 1. Okay, the velocity is 10 ms minus 1. For the second, t equals to seconds, I have to apply to the above equation. V equals to 0 plus 10 times 2, it is 20 ms minus 1. Velocity equals to 20 ms minus 1. In the third second, t equals to 3s. So velocity will be what? 10 times 3. Oh yeah, now 30 ms minus 1. ms minus 1. So now you can understand for any nth second, when it reaching to here under t equals to nth second, it will be velocity equals to na, acceleration multiplied by number of seconds. So it only suggests in each second what delta v is 10 meters per second. Here the difference, delta v is equal to 10 meters per second. Why? Acceleration means what? The rate of change of velocity. Oh, velocity change per unit time. Unit time means each second it change the velocity by 10 meter. හරිනේ? ඕක තේරුම් ගන්න බැරි තරම් බබ්බු ඉන්න විදියක් නෑ මෙතන. මේවා කොපි කරගන්නත් එපා. එච්චර බාල වැඩ. I don't need this one, but I need the other one a bit. ඒකත් ලොකුවට ඕනේ නෑ. පොඩ්ඩක් ඕන. For 1 second. Now it is about the displacement. I am not going to take the up in this manner. You have to show like t equals to 2 seconds, t equals to 3 seconds, t equals to 4 seconds. Let's find out the displacement in each case. S equals to half gt square. So we know another thing, half into g is 10 and t square, it is going to be just 5t square. You can apply 5t square for free fall easily. You can just keep that in your mind. For the MCQs, you can just apply 5t square and find the answer for what are in the for the first second. See, S1 5 times 1 to the power 2 is just 5 meter. Oh yeah, S equals to 5 meter. Now let's find that for the S2. S2 equals to 5 times 2 to the power 2, 20 meters. S2 is 20 meters. S3, 5 times 3 to the power 2, 45 meters. S equals to 45 meters. Right. S4 is equals to 5 into 4 to the power 2, 45 times 80 meters. Okay. හරි නේද? පොඩ්ඩක් මේ රටාව මතක තියාගත්තා නම් MCQ වලට හරි ලේසි. 5 20 45 80. Each time see it is increasing by what? 10 plus meters going to be like 10. So to the previous value, always 10 plus 5. This 5 and another 10, 15. Now see, here what happened? 20. You have to just double your answer. See? Double your answer and add 5. Previous answer, see? 20 meters. Right? Here, 45. So the difference is always increasing. See, 15 meters per second. Now it is 35. Difference is what? 10 here, 15 here, 35 here. In each second, you can see it has traveled some additional 10 meter. Additional 10 meter than the previous. Here just a 10. Sorry, difference is 15. So here 15. Sorry, no. Yeah, 15, 25, 35, 15, 25, 35. So see, previous value and another 10 added. Previous value and another 10 added. So the difference, always difference is 5 meter difference. Yeah, there is a difference in 5 meter. Now that 5 and 10, 15. Again, here, what is that? 20 meter, another 5, like that. So the difference is increasing by 10 and 10 and 10. You don't want to worry about that. You can have to remember like 5, 20, 45 and 80. So you can get this one really easily. Any value is equals to 5 t square. For MCQs, for other cases, you have to apply separately. Okay. Now write vertical projectiles. Now write vertical projectiles. Vertical projectiles. Second type of motion, vertical projectile. It is something like you just throw something directly up. U equals to something upward, and it will reach to the topmost of the motion. Finally, velocity will be 0. Why? Have a good look at when I just throw something up. In the top part, it reached to the velocity of 0, remaining there for infinitesimally small instantaneous time. හිතා ගන්න බැරි තරම් පොඩි time එකක් spend කරලා again return. See, in the top the velocity will be 0, and the acceleration is there, which is downward. So acceleration is g, but the acceleration acts as if a negative g because the initial motion is upward. Initial vector is upward. If you started at t equals 0, it will reach to here under some time of t, and the height factor that I don't know, whatever the height it will reach. In the previous case, we know the height. We know the height from where we drop. But here we have to wait for it to reach to the height. So height factor is also something we don't know. The reversal of the previous process. Reversal of the previous process. Now write this one. So copy this diagram. Until you to copy, I'll drink some water and come quickly. Okay, Ramai. Now right. Initially the motion was set to move upward. Initially the motion was set to move upward. Upwards. It was set to move upwards. So the initial direction is upward direction. And gravity acts downwards always. Gravity acts downwards always. According to vector notation, write this in a new line. According to vector notation, value of gravity here it is a negative component. It's a negative component. So let's find out the maximum height, H max. Initially, I know the V is 0, V. So finally, V square is equals to U square plus 2AS. U is something, here it is V. U square minus 2GH. So 2GH comes, 2GH is equals to U square. H is equals to U square over 2G. Tan, tan, tan. Copy this. H max actually, maximum height. Now I time of flight for the first half of the motion. I hope you had enough time. Time of flight for the first half of motion. Time of flight for the first half of motion. Okay, how? So you know that the time is initially 0 and reach to there. So we have to use, what is it? We know one thing. V is equals to 0, V equals to U plus AT. 0 equals to U minus GT. So here GT equals to U, T equals to U over G for the upward part. Quickly copy.
Okay, sir.
Now how about it? Can you understand the whole motion parts you learned so far?
Yes, sir.
Yes, sir.
Okay. Now write the time of flight for whole motion. Time of flight for the whole motion. What the heck? What the heck is this man talking about? Isn't that you are thinking now? Whole motion. If you have ever watched cricket match, so the cricketers hit the ball, it reach to high and just land. So this motion is just it is an upward motion as well as there is a path for downward as well. It just reach to there and come down. With the velocity downward is minus v. Why? When plus u, then when you change the direction, it is minus u. Velocity, final velocity is equals to minus u. Initial velocity is equals to plus u. Initially plus u, final velocity minus u. Oh, how about the total displacement now? Total displacement is what? 0. Why? Total vertical displacement is 0. It goes up with a positive h. It comes down with negative h. When you add plus h, minus h, finally 0. Can you understand?
Yes, sir.
Okay, now write, considering displacement. There are two ways to find out. Considering displacement. S equals to 0. 0 is equals to ut minus half gt square. That means I just apply this to what? S equals to ut plus half AT square. So this whole AT square comes to here. Half GT square is equals to UT. T and T cancel off, only one T remaining. T will be cross multiplication of these 2 times U over G. This is what your answer. Okay. Considering velocity, next step is considering velocity. Okay, we know U is just initially U. Final velocity is V. V equals to U plus AT is going to be my equation. V is minus U. Initially plus U minus GT. So this comes to here. GT is equals to 2U. T is equals to 2U over G. Whatever the way you take, you can get the answer. There is a very simple method, but physics we don't count that because in physics we have to go for kind of mathematical proof as well. Here the half time is like U over G. Only for the half motion U over G. Next half it should also be the same time with our kind of like cognitive activities. We know so we take like upward time should be equals to the downward time. If you just multiply this by 2, so equals to 2 times T here equals to 2U over G. So take it in this method. Cyrus? Hari. Mahanane?
Yes, sir.
Okay. Now there are some mathematical things and cognitive understanding things as well that you have to know. Analysis. All right. Analysis of motion. The time taken to pass certain point in between starting point to maximum height. This is H dash. This point is locating somewhere H dash. Point X. Okay. You can understand when this one just move upward, so there will be a time registered at here that is going to be T1 time when it is moving upward. So at this moment it is a T1, then it returns. See, when you return with the in the returning time, there will be a T of T2 also will register. You will get 2 positive values for passing certain point in the motion. Okay, there another? Yes or no?
Yes, sir.
Tell me with confident voice if you understood this.
Yes, sir.
Are you sure?
Yeah.
Other girl?
Yes, sir.
And
Yes, sir.
do you believe I took more than 45 minutes to explain this part in my regular physics class? T1, T2 කියලා දෙකක් ආවි කියලා. See, it is spent first time and the second time. First time here captured, second time when returning. ඔක return වෙනවා කියන එකත් උන්ට හිතා ගන්න බැරි අමුතු අප්‍රෝප ජීවියෝ ඉන්න තැනක්. So I told you it is S dash. So you can just apply to equation S equals to UT plus half AT square for this type of thing. H dash is equals to UT minus half gt square. So when you solve this, you can just find out answers in a quadratic equation. So you get like, this is going to be 5, no? You get like 5t square minus ut minus h equal to 0. Then you have to solve this in a quadratic equation and find out two positive values for t1 and t2. That's fine, because you guys are the first timer and this 2025 students are the first timers. But unfortunately, in the last night, one of my student just sent me a certain question that was a Sinhala medium question. It took some time for me to process while reading it. So, and I happen to know that Baga is doing some tuition classes. So, ඇයි සර් මෙහෙම වෙන්නේ? ඇයි සර් මෙහෙම to positive values දෙයක් එන්නේ answer එකට කියලා මම අහනවා. He's in some kind of like a private university, so he does some tuition classes for his wages, might be. Guy called Romario, the largest person I ever used to know. එන්න තඩියෙක්. ඉතින් මම දවසක් උඩවිලු කරා මේ රොමාරියෝ මම දැක්ක මේ කුරුණෑගල බස් එකක් මේ පැත්ත ගහලා යනවා. වහනවා අයිසර් කියලා නෑ. මම දැක්ක ඒක ඇතුලේ මේ එන තඩියකුත් හිටියා කියද්දි අම්මාස් මාව දැක්කද කියලා ඒ වගේ නිකාරේ. එතරම් තඩි. Like that. The thing is, now imagine he doesn't know the subject, but he teach. Marune. First you have to learn. Then earn. Then firstly learn. Firstly what? Learn. Then you cut your help and earn. But our people don't learn, try to earn. Because you are getting two positive answers in the upward direction. When it is move up, you register for the T1, it reached to 0. Under opposing force, it will now be an acceleration coming down. In the second time you meet the same point again, you get two positive answers. Okay. I hope you understand this. Okay.
Yes, sir.
So you may apply the values and find out the answers. But don't worry, in our local A-level system, we have to solve no quadratic equation. Quadratic equation never solve karanna ඕන වෙන්නේ නැහැ. But in term test, you will have to, none of you do the term test because you guys are not going to schools. In real A-level, මේ T1, T2 කතන්දරයක්වත් අපිට හොයන්න නැහැ. Guarantee කරලා කියනවා ඕනේ. But I will teach you the theory. Now imagine you may have to travel certain distance upward from that point as well to another point that located at some h double dash height. I told you it takes some time of t1 here. So to reach this point, it will be like t3 returning journey, t4. So it will take some time. What? Delta t2 move up t3 minus t. This is nothing other than, what is this delta t? t3 minus t1. When returning, it will be another delta t. What is it? Delta t is equals to t2 minus t4 here. But you have to know upward time difference should exactly be the downward time difference as well. MCQ වලදී ඔයා ලස්සනට check කරනවා. තේරුණාද මම මේ කියපු කතාව? The upward time difference should be equals to the downward time difference if the height is the same coordinate points x and the other point of y. If it is between the same x and y, to move up, it will take some time of t dash delta t. It will take the same similar amount of time to descend as well. Other
Yes, sir.
under තේරුණා
Yes, sir.
So this motion is not limited to this type of stuff. It is going to be extended even more. Now shall I erase? So are you going to copy? Have you already copied or going to copy?
Done, sir.
Others?
Yes, sir, done.
Oh, this is why I really like you guys. Doing work like bullets. My regular classes, I really hate them because these buggers take longer time. Please keep it, and still copy. I'm sick of them. Okay. Now, sometimes you project something upward and reach the final level is not the same ground level. Building එක slab එකක් උඩ ඉඳන් උඩට ගලක් ගහනවා. It will fall somewhere below the ground level, sea level. So it is negative edge because your initial motion is upward, acceleration is downward and reach to 0, and finally it reach to here with the velocity unknown, but the time something that is also unknown. For this type of motion, that is also in the term tests only. In the A-level exam, you don't want to worry about these quadratic factors. So finally, you will have to apply to the equation here s equals to ut plus half at square. So s is negative h, right? Motion is against the positive motion. Initially, you throw to here. That is your positive. Anything downward is a negative. Minus h. Ut minus half gt square. I told you gt square means 5 t to the power 2. When you resolve it, you can get it like t to the square minus ut minus h equals to 0. Then you will just have to tackle certain quadratic equation and find out the time factor here. Understood or not?
Understood, sir.
Understood?
Yes,
Say yes
sir.
if you got. Oh, nang ho gaya na.
Oh, sir.
Others?
Yes, sir, understood.
Copy it. Actually, on a motion under gravity, I took entirely 1.5 days to explain this shit to them. 1.5 days. එසි නෑ දවස් එකමාරක් ගියා පැය 4මාරක් මේ වගේ විහිළු ලෙසන් වලට දවස් 4මාරක් අයින් කරනවා කියන්නේ අපරාධයක්. There are good ones in future. Electronics, electrical, magnetism, that we actually have to give really good time because they learn that for the first time. Unfortunately, we have to lay the foundation for many long years, like 1.5 years for the mechanics and the basic things. Then for the last year, we have to just hurry up everything. The new things with really good concepts, they have to absorb very faster. Actually, the unwanted things, they have already spent their valuable time. අනිකර බූරෝ ගොඩක් ඉන්නවා බූරෝ ටික කඳව ගන්න සර්ලා හිමීට කරනවා මට කරන්න දෙයක්වත් නැහැ. ඇයි? මාත් අසරණයිනේ මන්ට හයියෙන් කරනකොට මුන් බලනවා අපු අර සර්ලා හරි හිමීට කියලා දෙනවා මෙයා නම් 20ක් හයියෙන් යනවා. මුන් දන්නේ නැහැ තව වෙන කන්දක් වගේ තියෙනවා ඉවර කරන්න කියලා. කවදාකවත් ඔය අයියලා අක්කලා කියන දේවල්වත් අහන්නේ නැහනේ. උන්ගෙන් අහනවා නම් කියයි අම්මෝ මල්ලි ඔය මේ මෙකැනික්ස් වලට අතක ගා ඉන්නවා කියන්නේ අපරාධයක්. ඉස්සරහට සුපිරි ලෙසන්ස් ටිකක් තියෙනවා කියලා. නෑ නෑ නෑ. ක්ලාසස් වල බූරුවා කරනවා මුනුත් අසේ බූරුවා වෙනවා. නෑ. හරි. copy this. Okay. අපි යමුද අපේ virtual board එකට ගිහිල්ලා. හදමුද ගණන් ටික. Ad. Okay. Lamai, say yes.
sir. Yes, sir.
We forgot to record. It is like S equals to ut plus half at square. S is equals to, it is a negative edge. You don't want to put the negative at the beginning. Equals to 20 times 5. Here it is like the half to 5 into 10 into 25. Then half into 10 is like 5. So 100 minus 125. This minus 25 meters. Speed of the ball just hit as it hit the ground. Okay. We have to write like this way. V, I don't know. U, I know. A, I know. So the stuff is like we want to find. We can apply V equals to U plus AT. And the time also we know. 25 minus 10 times 5. Sorry, 20, only 20 here. Minus 30. Did you get these two answers?
Yes, sir.
Okay. A car passes a point with 20 kilometers per hour. It accelerates constant rate and 10 seconds. It passes point B with 70 kilometers per hour. So here, I have to convert this to leave it. Here, convert it to 70 into 5 over 18. This is U, this is V, and the time is there. Yeah, we have to apply V equals U plus 80. Twenty-five over 18. That means nearly 1 point is like 70, 3. Again, like, yeah, 8. 1.38 seconds. Yeah, sorry, ms minus 2. Did you get these two answers?
Yes,
These
sir.
answers? Yes or no? Did you get these answers? Hello? You can apply to here. Five. 5 times 5 times 5, 5 times 5, 25, 25 times 6. S will be 125 meters. Did you get these two answers, Lamai?
Yes, sir.
Others?
Yes, sir.
A stone is dropped from a point 120 meter from the ground. Find the time takes from the stone to reach the ground. U equals 0. Did you get these answers? Did you get these answers? Yes or no?
Yes, sir.
Very simple. 20 root 6 ms minus 1. Are you there?
Yes,
Yes, sir.
Okay. Question number 5 and 6 are not related to this one. It is about like a brain thingy. You can just write home because it is a different type of question. So now I think we have done enough of this. We have really done enough of this one. You can have the first interval of likes of 10 minutes. After that, we can start off with the new one, very new theory called horizontal projectile. Okay, Rama, are you ready?
Yes, sir.
You have 10 minutes now. The first interval begins.